So I'd like to walk you through the example that we went to in class today. We got through the first part of it in second period, so the second and third parts will be new to you. So we launched a projectile at 132 feet per second at 50 degrees from an initial height of 2 feet, and we were asking the questions, how high does it go, how long is it in the air, and how far does it go? So remember, the first thing we had to do, because projectile motion, the horizontal and vertical parts are independent of each other, we had to take that initial velocity and break it up into its vertical and horizontal components, v sub x and v sub y. So my angle was 50 degrees. My initial velocity goes on that hypotenuse, and you use trig ratios, cosine, to find the v of x, and sine to find the v sub y. And when we found those, we got 84.85 for the v sub x. That was in feet per second. And 101.12 for the vertical component of initial velocity. So when we were dealing with the horizontal motion, the position, because there's no acceleration, this first term here would go away. And you'd have v sub x, which is 84.85 times time, and the initial position in horizontal stuff is 0. And then with the vertical motion, it's s of t equals 1/2 a, and the acceleration is the negative 32 here, so that'd be negative 16 because it's 1/2 a, t squared plus 101.12 t plus 2. We talked about all that in class. And the first question we said was, what's the maximum height? So we found that the maximum height occurs when the vertical velocity at any time is 0. So we found the equation for the velocity at any time, and that is this with the appropriate stuff plugged in. So my gravity, negative 32 times time, plus my initial velocity in the vertical direction, which was 101.12. When you set that equal to 0 and solve for t, you get 3.16 seconds, which is how long it takes to get to the height. And then you take that and plug it into the vertical position equation to get what the maximum height actually is. And we calculated that that was 161.77 feet. So that's how high it goes. The next question is, how long is it in the air? Well, it's in the air until it hits the ground again. So when it hits the ground again, the height, the vertical position, is 0. So it hits the ground when the equation for vertical position equals 0. Now that is this thing for this problem. So if I take that equation and set it equal to 0, it will give me 2 times, because this is quadratic, and I would solve this with a quadratic formula. I'm not going to show all that work, but when you plug that in and you do the quadratic formula, you get 2 numbers. The first is negative 0.0197, and the second is 6.3397 or 6.34. Now this first thing, this negative number, you know it can't be negative, but that number kind of makes sense, because when the ball or the projectile was thrown, it was thrown from an initial height of something like, what, 2 feet? And the motion looks something like this. Well, if the ground is here, right, there may have, if you think of it just a parabola, there would be another x-intercept back here, but it's irrelevant to the problem that we have because we started the motion right here. So you're pretty much always, unless the thing starts from the ground, you're always going to get a negative number here. you can always ignore it because it happens before we actually, I mean, it doesn't actually happen in the problem. So the number we care about is this. This is how long it takes to hit the ground from the time when it was starting its projectile motion. So this is how long it's in the air. Now, if I want to find how far it went, this is how long it's in the air. This is the description of how far it is horizontally given any time. So if I take this number and plug it into there, it will give me the distance it traveled in that 6.34 seconds it was actually in the air. And when I calculate that, that gives me 537.95, and the units on that would be in feet. So the maximum height is 161.77 feet. The time it's in the air is 6.34 seconds. Should have put seconds there. And then the distance that it goes is 537.95 feet.